Okay, hello grade 8s. We are getting into a new unit. This is called squares and square roots. So we're learning all about squares and all about square roots. Very exciting stuff. So we can see some squares here. So what is a square? This is important that we think about it. Well, a square is basically a rectangle with the same side lengths. So all of the side lengths are the same. So a little bit of review that we need to know is we need to know the area of a rectangle is length times width, of course, but an area of a square would just be the side length times the side length, because we don't have two different side lengths. If this would be S and this would be S as well. Whereas in a rectangle, right, we would have two different side lengths because a rectangle looks like this. So we have a length and a width, we would have a length here and a width here. But in a square, we just have two, they're all the same. So the area of a square is side length times side length. So this is going to be the square area. Okay, we need to know that. That's important for this unit. We need to understand that a square has 4 equal sides. I'm sure you've all heard that before in your math career. So with that, let's get into it now that we understand what a square is and how we deal with it and how we deal with square roots. So let's start with our key terms. So these are the key terms that we're going to need to know for this unit. Prime factorization, which is a process that we're going to go through in order to find the prime factors of a number. So it's a number written as a product, which is a product is multiplying, right? So this is timesing, multiplying, okay? Of its prime factors. So we also need to know what a prime factor is. And a prime factor is a number that multiplies with another number to produce a given number. So it's like and it's all the way in its lowest term. So when you divide it all the way down is what a prime factor is. We're going to see an example of that in a second. And then we also need to know what a perfect square is. A perfect square. So a perfect square is a number that is the product of the same two factors. So a perfect square, let's give some examples here. So you can see I drew a square. So a perfect square would be a number like, so a product of the same two factors. So if we took a number like 2 and we times it by 2, we would get 4. 4 is a perfect square. Okay, if we took a number like 3 and we times it by itself, we would get 9. 9 is a perfect square. Okay, if we took the number 10, how about that? 10 times 10, we would get 100. 100 is, you guessed it, a perfect square. Okay, and so the reason for that is because you can almost imagine as if these numbers here, like 10 and 10 and 3 and 3 and 2 and 2, are the side lengths of the square. So we're going to see more examples of this. But for example, if our square had the dimensions of 10 and 10, of course our area would be 100. Okay, so that's what a perfect square is. Okay, so we got that down. So let's get into some of our problems and things we're going to encounter in this unit. So let's start off with prime factorization. Okay, prime factorization. So what this means is taking a number and breaking it down into its prime factors. Okay, so let's pick a number. Let's start with a number like 24. Okay, so if we have the number of 24, we need to now break it down into its prime factors. So we need to think what times what equals 24. Well, we could do something like, how about 4 multiplied by 6? Because 4 times 6, right? 4 times 6 equals 24, okay? And that's true. Now, can we break 4 down even further? What times what equals 4? Well, we just did that. 2 times 2 equals 4. And what times what equals 6? Well, 2 times 3 equals 6. Okay, now these numbers, 2, 2, and 3, we can't break down any further without using the number itself. We can't, there's nothing that would multiply to equal 3 other than 1 times 3. So these are now in their lowest. So these are called prime factors, okay? So these prime factors, very nice. So that's good. Now we can see what a prime factor is. This process of creating our tree here is prime factorization. So this is the process of prime factorization, what we just did. And you'll notice on this tree, could be called a factor tree. Each layer, so this layer, oh, that's not very clear, but this layer, this top layer, right? This middle layer and this bottom layer all equal 24. 24 is obviously 24. 4 times 6 is 24. 2 times 2 times 2 times 3 is also 24. Okay, so that is important to note about the factor tree is they all equal our number at the top. So let's do another one. So let's take the number 36. How about that? And let's break it out. So 36, we could multiply. What do we think in here? Well, we could do 6 times 6. That would be quite nice. And then we could break 6 into 2 and 3. And once again, we could do 2 and 3. So now we have 6 times 6. We have 2 times 3 times 2 times 3. Okay, and so there we just did the factoring tree of 36. So that's that. Why don't we do another one? Let's do the prime factorization of, how about 81? Well, 81 would be 9 times 9, and we would have 3, 3, 3, 3. Very nice, very easy. So this is the process of prime factorization, okay? Taking a number and breaking it down into the smallest factors, prime factors, right? So all these numbers are prime factors. And we can see, yeah, each of the different layers equals our number at the top. So 81 or 36 or whatever that is doing when you multiply them together. Okay, so this is the process of prime factorization, all of these things. So we need to know how to do that. Okay, very nice. Now, there's another way to figure out a perfect square. So remember, we learned that a perfect square is a number that when multiplied by itself equals another number. A perfect square is the when two numbers that are the same multiply to equal a number. So 4 is a perfect square, 9 is a perfect square, 100 is a perfect square. Okay, so there's a trick when you do prime factorization to figure out which numbers are perfect squares. We can count the prime factors, and when down here I wrote it. So a perfect square is when the prime factors appear. I should have wrote appear there. This should be appear an even number of times. So what does that mean? Well, let's look at our examples. So let's look at 24. So how many times does 2 appear? It appears once, twice, 3 times. Okay, so 2 appears 1, 2, 3 times. 3 appears once. Okay, so these are an even. This is odd, right? 3 is an odd number. So that's an odd number of times. 2 appears an odd number of times. And 3 appears an odd number of times. So we are looking for when they appear an even number of times. So 24 would not be a perfect square. So sorry, 24, you are not a perfect square, X. Okay, let's check our next ones. So 36, we have 2, and it appears 1, 2 times. Okay, that's so far so good. That's even. We also have 3, and that appears 1, 2 times. So these are both even. Even and even. So congratulations, 36. You are a perfect square. Very nice. And we can see that it would be right here 6 times 6, right? Because it would be our perfect square. So let's check out 81. And we can see already 3. We have 1, 2, 3, 4 threes, which is once again even. So congratulations, 81 is also a perfect square. Okay, so that is a little trick you can use to figure out the perfect square with prime factorization if you want to use this method to find perfect squares. So let's look at some questions we're going to get. So determine the area of a square. So remember, we said the area of a square is the side length times the side length. Now, another way we could write that is we could write the area of a square is the side length squared times 2, the side length squared. So when we write a little mini 2 up above, it means squared. Okay, side length squared. So these two things are the exact same thing. They mean the same thing. S times S is the same as S squared with a little 2. It's even called squared. Okay, so let's try to do this problem here. So we can see that our picture frame over here has 13 centimeters on either side, a side length of 13. So S equals 13. Okay, so let's plug it into our formula. A equals 13 squared. Okay, now we can solve for this. So we could do it this way. We could also rewrite it again as this, 13 times 13. This is all the same stuff. This all is equal. It all means the same thing. So 13 times 13 is 169. So that is going to be our answer to our problem. Okay, 169. Now, the trick is we're not done because we have to write our units, centimeters, but we don't just write centimeters. We actually write centimeters squared. Okay, area is always in centimeters squared or meters squared or kilometers squared because we are talking about the area. Okay, that's inside. We're not talking about a length. We're talking about a squared area. Okay, so you can almost imagine as if you divided this thing into a grid, right? Like this grid. And we have 169 little squared centimeters inside of there. So that's kind of how you can think of that. So area is always in centimeters squared. So remember that when you're writing your answers for area. Okay, so I hope that is clear on how you determine the area of a square. You just plug in your side length and you multiply it by itself. Okay, determine the square root now. Okay, so square root has a cool sign like this. It's almost like a check mark with a line above like that. So that's the square root symbol. So Edgar knows that the square case for his computer game has an area of 144 centimeters squared. What is the side length of this case? Okay, so let's draw a picture. I always like to draw pictures. So here's our case, okay? We know the area is 144 centimeters squared, and we need to figure out our side length, okay? So this is a question mark. We need to figure it out. So we need to figure out S, okay? So I'm going to put it as S. So we know that our area equals S squared, right? And so what we could do here is if we find the square root, so 144 equals S squared, right? Now, if we were to find the square root of 144, this would give us S, okay? So this is how we would write it. Square root of 144 equals S. And now in this case, if we know our multiplication tables, we might be able to figure this out quite quickly. So, but if not, I'm going to show you a way that you can figure this out if you don't know your multiplication tables too well. So the square root of 144, well, what we could do is we know that 144 is S squared, right? So 144 equals S times S. So we could just try numbers in here that we think might be the case, that might be close, okay? And obviously we would want to make some educated guesses. So what if we tried 10, okay? So let's put 10 in. 10 times 10. 10 times 10 equals 100. So it's too low, right? So it's not 10. It's got to be higher than 10. So let's plug in another one. What if we try, I don't know, why don't we try 13? We just did 13 on the last question. So 13 times 13, remember that over here? 13 times 13 is 169. So now we're too high. That's above 144, right? We're too high. Okay, so what if we tried 12? 12 times 12 is, what do you know? 144. So our answer, the square root of 144, is 12. Okay, so now we know our side length over here is going to be 12. 12 centimeters. We got to make sure we write our unit of centimeters. So that is square root. Okay, so if we took, let's do just like one more quick example here. So let's see, can I get a blank sheet? Well, maybe not. I think I saw a blank sheet over here. So let's see. If we do the square root, so we found the square root of 144 equals 12. Okay, if we did the square root of, what about 4? Okay, This would equal 2. And the reason for that is because 2 times 2 equals 4. The reason for this one is because 12 times 12 equals 144. Okay, so we could also do the square root of 9 to get an answer of 3. And that's because 3 times 3 equals 9. Okay, so are we kind of seeing the pattern here? So a number times a number will get you a perfect square. So these numbers over here are all perfect squares. Okay, so I hope we are following. Make sure you send me an email, come to class, ask me a question, and we will see you soon.